Hello, everyone. This is Melly Annamalai. I'm a product manager for some of our big data products at Oracle, and today I wanted to talk about a fast loader to load data from a Hadoop environment into an Oracle database. I hope everyone can see my screen. And if not, please send me a chat message. I'll just give it a minute or two, and then I'll get started. So I'm planning to maybe talk for like 10, 15 minutes, and then I'll just go through some scripts. I'll run a small demo in a VM. Okay, I'll get started now. Once again, I'm Melly Annamalai, product manager with the Oracle Big Data team, and one of the products I work with is a loader to load data with high performance from Hadoop to an Oracle database. So let's get right to the product. So like I said, I'll just talk for a few minutes, 10 minutes or so, and then show a demo. And the format is really discussion. So I want to spend more time on the Q&A. So I thought I should just talk very briefly about Hadoop for those of you who might not be familiar with Hadoop. So Hadoop is a technology that has been getting increasing. Hadoop is a technology that's been getting a lot of traction, a lot of success. Can you mute your line, please? Okay, I'm going to, I think, mute everyone. Okay, so I'm back. I think I successfully muted everyone's line so we wouldn't hear the disturbance. So talking about Apache Hadoop. So it's a technology that's been getting a lot of traction, a lot of interest, particularly from the data warehousing world, as a way to process large amounts of data. Apache Hadoop is an open source software framework for distributed processing. So you can see here that I have 25 nodes connected together. Often these are just commodity hardware boxes. The elephant is which has become the kind of the symbol of Hadoop, and there's an interesting story behind it. So the point of Hadoop is that it allows you to process large amounts of data in a distributed manner using a bunch of boxes connected together. And you can easily do scale out. So let's say I have the 25 nodes, but I want to add some more nodes. I can keep adding more nodes to get linear scalability. So if I'm running something with 25 nodes and I just add 50 more nodes, 25 more nodes to get a total of 50 nodes, I've just increased my computing power. I've just doubled my computing power. So it works really well to process large amounts of data in a timely manner. So the classic examples are you're processing and mining weblogs, like how you're a retailer and you want to track the activity on your website where people are clicking on products and maybe not buying the products. So you want to see why people are clicking on some things but not putting it in their shopping cart. So things like that. That's a classic example of a weblog. Social media feeds. You might have Twitter feeds coming in as JSON files, and you're tracking a particular event associated with your organization or your business. And you want to kind of mine the data, pull out the relevant pieces of information, and then use that in further analysis. So, but when you're getting these large volumes of data, the unstructured data, the weblogs, and the social media feeds, you want to be able to process them in an efficient manner, and that's where Hadoop is really good at doing that. Because it's a shared nothing architecture, you can just take all of these log files, distribute them across all the nodes, and operate on them in parallel. There are ways to communicate between the nodes, of course, but it does a really good job of operating on all of them in parallel. So that's Hadoop, and like I said, we are seeing our customers increasingly want to use Hadoop to process this data, but then they also have their business critical data in the database. So how do they bring the results of their processing on Hadoop into the database? So some formats of data or some types of data they would have on Hadoop are text files, typically comma-separated files, log files, like I mentioned, Apache log files, and other log files that might be coming from various input sources. JSON files, again, the classic example is Twitter feeds. You can download Twitter feeds as JSON files, or JSON is anyway getting very popular too for representing all kinds of data. Sensor feeds, I mean, BP monitors from patients and so on, or which are just sending in information every second, monitoring a patient, or maybe sensor data, maybe geological sensors, monitoring geological activity, seismic activity. So you want to get all of this data, and you want to only identify the places where it's interesting. Because a lot of the sensor data, for instance, nothing is happening for a while, but then something happens, and you want that's the data you're interested in. And Hadoop can do that filtering and get only the relevant data for you. So, okay, so we are doing all of this processing on Hadoop, and then we want to bring that into our data warehouse in our database. So for that, we need to load the data, and that's what Oracle Loader for Hadoop is. It takes the results of your Hadoop processing applications and then can do a very high-speed load to move that data into the database. So what does it do exactly when it loads? You can think of it a little bit like SQL Loader, except it works with Hadoop. So SQL Loader loads from data into the database. So Oracle Loader for Hadoop does the same thing, but loads from Hadoop. And in doing so, it really leverages the Hadoop infrastructure. Hadoop, as I said, has a lot of nodes. It can operate on data in parallel in a distributed manner. It leverages that feature of Hadoop to get really a high-speed load into the database. So for instance, what it does is to load the data, it processes and transforms the data and converts it into Oracle-ready types. So let's say you have this Apache weblog files. You've done some processing of the data. You've identified relevant bits of information. You have this information. Now you want to load this data into a database. What we do here as part of Oracle Loader for Hadoop is we look at the target table first. We get some information about the table. We get the data type information, the column type information, the structure of the table, whether the table is partitioned, and if so, the partitioning key, and so on. And then we take the data that we're going to load, and we process and transform it into Oracle types. So if you have data going into a number column, we transform the data into an Oracle number type. And this is particularly important because there is no real concept of type on Hadoop. Data is just strings and files eventually. It could be compressed and it could be log files and so on, but finally it's just text. So we do the transformation from the text data into number data or date data, whatever, depending on the columns you're loading into. We do the transformation on Hadoop and then load. So that gives us, one, it gives us high performance load. And the second, it really minimizes the use of CPU cycles on the database. So if your data warehouse is running critical applications and you have this huge volume of data coming in, this kind of just works quietly in the background without taking up too much database resources. We also get the high performance load by leveraging the, like I said, the distributed network of servers. So we are actually, when we actually load multiple nodes on the Hadoop side, we'll be connecting to the database and loading data in parallel. So to summarize, Oracle Loader for Hadoop is a tool for fast load from Hadoop to Oracle database. And it's particularly good at coexisting with business critical applications running on the database because it uses so little database CPU because it offloads as much of the load transformations as possible onto Hadoop. So you can see here that it can load text files, log files, JSON files, and so on. I've also included some Hadoop technology. So Hive is a SQL layer on Hadoop. It's a SQL layer that allows you to query data in files. That's something the Oracle Loader for Hadoop understands. So you can just point it to a Hive table and then load data from there. Parquet is a columnar compressed format that was created by Cloudera, Oracle's partner in the Hadoop when it comes to Hadoop distribution. So we can load data compressed as a Parquet format and so on. So we understand different data formats and different technologies in Hadoop to create the optimal path for loading data into the Oracle database. So here's an example just to show loading from Apache log files. So let's say here's a log file that contains clickstream information. It gives IP addresses, timestamps, and other information. So let's say you're only interested in the IP address and the timestamp because you just want to know who is clicking from which location, and you might be able to map the IP addresses to a geographical location in a different application. So here, if you just want to pick up the IP addresses and the timestamp information, you can do that with Oracle Loader for Hadoop. It would parse the data, parse this file, so pull out these two columns, and then transform it into the appropriate types of the database, like the IP address would be varchar2, the timestamp would perhaps be a date column. It does all the transformation and then loads the data. Here's how we would submit a load job. So Oracle Loader for Hadoop is a Hadoop job, and it is a MapReduce job if you're familiar with the different types of Hadoop jobs. So MapReduce is a type of job which has two phases, a map phase and a reduce phase. And in the map phase, you're distributing the data to all the nodes. And in the reduce phase, you are grouping the data according to a particular characteristic and then doing a final operation on the data. So when it comes to Oracle Loader for Hadoop, in the map phase is where you transform the data into Oracle types. And in the reduce phase, you group data by partition. So if your table is partitioned, your database table is partitioned, you group data by the partition key and load each partition in parallel when you're running this job. So you submit this job from the command line. If you're submitting this from the command line, you submit this as though you submit any other MapReduce job. So you say Hadoop, and this is the jar file that contains all the loader that you're basically running. And then you have this XML file that contains the configuration parameters that will be used in this job. So this could be passed in the command line too, but if you have a lot of properties, it does make sense to have this all in a file. And here's an example here. We are telling it here that the input format is text. It's in text, delimited text input format, meaning we are loading from comma-separated files. And we have here an input directory giving the location of the data. We are saying that the field terminator is a tab. And we're saying we're going to be using the OCI direct path load. So you can load either by having a JDBC connection or with OCI direct path load, which kind of goes below the SQL layer, as you might know if you've used SQL Loader with this in the direct path mode. So it uses the same direct path mode, so it's much faster. So we always recommend the OCI output format. And we have some other table information. I will show you the full example when we run this example. Just before we run the example, just wanted to run through some key features, performance. We get load speeds of 4.4 terabytes an hour end to end. This includes the processing time on Hadoop and the load time. This is from a benchmark running on Oracle's engineered systems connected by InfiniBand. But we've noticed that you don't need to have an InfiniBand. You could just have your standard network and you would get similar speeds. Your bottleneck is usually not the network. So we've seen extremely good performance and extremely good, very low usage of database CPU, as I said. And there's one more interesting feature that I wanted to highlight. So when you're loading data and you're using a network of servers which are operating on the data in parallel, a classic challenge is each node might not have the same, might not do the same amount of work. In other words, each node might be operating on different size data. The data might not be evenly distributed. So one node might end up working on more data than another node. And when that happens, that slows down your load process because you have this one node here spending more time than the other nodes. And your load time is only as good as your slowest node. So you really want to distribute the data evenly as possible when running a job on Hadoop. And Hadoop has some tools to do this, to distribute the job evenly. But we have an innovative way of doing this better so that we sample the data, we do an intelligent sample of the data, and we distribute the data evenly. So it's a data-based distribution. We understand the data distribution and then distribute the load to different nodes accordingly. So this intelligent sampling, so here's an example of a data set which was queued. You see here that some of the nodes sort of operated on a lot of data compared to some other nodes, and some nodes are just idle because of make that and evenly distributed across all nodes to get better performance. Some resources, the examples I'm going to show you can be downloaded can be run on Big Data Lite VM, which has a one node Hadoop cluster, a 12 database, and the connectors all installed, the Oracle Oracle Hadoop all installed. Oracle Oracle Hadoop is licensed as part of Oracle Big Data Connectors. That's why you see this here. So you can run this example later if you like in that VM, and we have our Oracle pages and an OTN page which contains other information. And we also have a blog and discussion forum. So with that, I'm going to check whether any questions in the chat box, and then I'm going to go to the demo. Okay, so I don't see any questions in the chat box. So maybe I will do the demo and I could unmute lines. So that would make it easier to ask questions. Okay. So I have here this Big Data Lite virtual machine, which is, like I said, has a one node Hadoop cluster and a 12 database. So these terminals on the left are Hadoop, and this terminal on the right is the database. So we see here I'm connected to the database, the movie demo schema, and I'm going to look at the table here that I'm going to load into. So this is the table that I'm going to load data into. And we see here this is, okay, here we go. So this is an example. I'm going to be submitting this job, and this is what I was showing you just now as an example. I have specified one property here in the command line, and this is the number of reduced tasks. So this is a Hadoop property, and as I said, Oracle Loader for Hadoop is a map reduced job, and the actual load is done by, that is the actual pushing the data into the database is done by the reduced node. And here I'm telling you to use 2 reduced tasks. If you had a 64 node cluster, you would presumably use 64 reduced tasks or even more, or it would depend on what other Hadoop applications you're running and how much resources you want to spend on the load on the Hadoop side. So here, this is an example. I'm saying let's use 2 reduced tasks. And now let's look at the other properties that are in this file. So here, so I think I showed some of this. I said, well, here is where the data is in tab delimited format. And here is the data file itself. And this is a field terminator. And what we didn't look at, I think, is the table information. So I'm giving the table, the name of the table, and I'm listing out all the columns that I'm loading into. And you don't have to list out all columns. You might just be loading into a few columns in a table, and you could just list the names of the columns you're loading into. And here is the Oracle database date format that I'm going to be using. I transform the data and the database connection information and so on. So I'm going to see whether we can take a look at this data, which might be interesting, to see the data we are actually loading. So I'm going to access this data from the Hadoop file system. Okay, here we go. This is the data. So all Hadoop commands are prefixed. I mean, this is how you access the Hadoop file system. You say Hadoop file system, and then you have the standard Linux commands that you can use to access data from the Hadoop file system. So here's the data, some of the data you see here. I think the customer ID, session ID, you have timestamp information, and you have a whole bunch of other information separated by tabs. Just wanted to show you the data. So now let's run this script. So this is going to kick off a MapReduce job. The first thing it's doing here is deleting this temporary directory that was created in the previous run. And this is just standard Hadoop setup time. It's basically conceptually figuring out, taking your data and distributing it among the nodes. Here, of course, I have only one node Hadoop cluster, but that's what it is doing. It is accessing the libraries. And then soon it will start the MapReduce job itself. So interestingly, it noticed while doing the data transformation, it noticed that there was a date which was not parsable. And this is generated data, so we were trying to figure out why this date was not parsable before realizing that this date in 2010 was the day I think we had the daylight savings time. We moved from the winter time to the summertime. So the time between 2 and 3 a.m. did not make sense. So 2:23 a.m. was not a valid time. So the data transformation that I was talking about, where it looks at the data format, the date format of the database that you're transforming the data into, that had identified that this was not a valid time, so it had rejected this data, this row. And this row is stored in a bad file. So similar to SQL Loader, where bad rows are put in a bad file or a log file, here this row is stored in a bad file in the Hadoop file system. So you can see here that this was the sampling time, which is the time taken to sample the data to do the load balancing. Again, we have only one node here, but I've included the sampling just to show, kind of include it in the example. So now here you can see that you had the map phase, another reduce phase has started, and it is just about finished loading. And it did skip that error because it basically was not a valid time. And this row will be stored in a bad file in HDFS. So now if you go and query this table, you should find the rows loaded. Yeah, 4526 rows. I think total data was 4527, but one of them was not loaded, so 4526. So just to show you some of the output while using this loader, I'm now again doing a Hadoop FS, meaning I'm accessing the Hadoop file system. I'm going to be listing the files in the temporary directory that was created as part of this load job. And you can see here that there's a success flag here indicating the success. And in the _OLH directory, you see a bunch of files, including this bad file, which is going to contain the data that was, the row that was not loaded. And you have a whole bunch of other information, reporting information. Some of this makes sense, some of this is just for internal use. So we can just take a look at that, the bad file. Oops, I should have said cat. So it's showing you the row that didn't load, and again, it is because of this problem date. So that brings me to the end of what I wanted to show. So I'm going to unmute lines so that we can have questions over the phone as well in addition to the chat. Feel free to ask me any questions on other Oracle products, working with Hadoop or anything on those lines. The Big Data Lite VM is a good resource. I'm just going to show you, oh, it's taking a while, from where it can be downloaded. So this, if you just Google Oracle Big Data Lite VM, you will get this location. And this has the virtual box that you can download. And it has instructions for running a whole bunch of things, including Oracle Loader for Hadoop that I was just demonstrating. So this is a nice resource. So to summarize once again, Oracle Loader for Hadoop is a fast loading tool to load data from Hadoop into the database and taking advantage of the unique properties of Hadoop, which is distributed processing, often with these commodity servers. So if you're building applications on Hadoop and you want to load data into the database, this is a really nice tool to look at. And there are some open source tools out there But we have seen that for when you're loading large amounts of data and you want a tool that really understands the Oracle database and understands the internals and is able to exploit that knowledge to do an efficient job and be a robust tool, then Oracle Loader for Hadoop is far improved compared to the other products available. So if there are no more questions, I think I'm going to then end this session. Thank you very much for joining, and I hope I hope this was useful to you.
Thank you.
And perhaps I'll talk to you at a future session on a different big data product.